Jai Jendra, Namaste and welcome to my channel. Today we are going to solve the 53rd question of the problem solving series and the first question of heap data structure. The difficulty level for this question is easy and this question has been asked in Facebook, Amazon, Microsoft, LinkedIn and multiple companies. So what is a heap data structure? Till now we have discussed arrays, binary search, greedy, stacks, queues, and now we are discussing the heap data structure. So heap is a complete binary tree data structure that in which the root of the node is always greater than or equal to its children, right? Or if it is there are two types of heap. One is max heap and the other is min heap. So for max heap, the root would be the root of the node will always be greater or equal to its children, or for min heap, the root of the node will always be lesser or equal to its children. So what is the importance of heap data structure? So we use heap to implement priority queue, and with the help of priority queue we can solve a lot of problems. Even we use heap, there is a heap method to sort heapify. It is called heap sort. It is called heap sort, where we sort the array in order of n log n only. So we use the heap data structure. So what is priority queue? Priority queue is a queue where the queue is arranged based on the priority, and the priority is mostly that the root of the top element of the queue is always the largest element that is present in the queue. So you need to study about heap data structure before solving this question. I would believe you know about the heap. You know how do we use heap as a priority queue library in C++ STL, and we will solve this question right now. So I'll suggest, if you don't know about heap, please study about heap in Geeks for Geeks or any other platform. You can Google about it, heap data structure, and you'll know how heap helps us to solve the problem in a better optimized way. So with the help of heap, when we extract the elements, since the element is at the top, so whenever we have a number of elements in the structure, and when we enter new elements, to get, so every time we need to heapify it, and that heapify can be done in order of log n, since we maintain the hierarchy of the root of the element to be greater than the children. So in that way, in a complete binary tree, this heap data structure helps us to extract the element in order of log n. Instead of the maximum element in a queue, we can extract in order of log n instead of searching for all the elements. That takes order of n. So in this way, heap optimizes our time complexity. Okay. So yeah, please study about heap, and let me discuss the question. Find the kth largest element in an array. So we are given a nums array. Okay, you can see this example 3, 2, 1, 5, 6, 4, and we are given k. So k is the, like here in this example, we need to find the second largest, kth largest element in the array. So this is a variable here. So we need to find the second largest element in this array. So this is very simple. If you don't know about heap, also you can solve this. How would you solve it? Like, you know how to find the maximum element in the array, right? So you can find the maximum element in the array by searching for the max, right? And if it is second max, third max, you can use that way to find the elements. Or otherwise, what you can do, you can sort this. So if you sort this, you'll get, if you sort it in a descending order, so you will get the elements in the order of 6, 5, 4, 3, 2, 1, right? And then if you need to find the second largest, right? K is 2. So the second largest would be 5. So you will return 5. So this is one way to solve this problem. And since we are using sorting, so the time complexity would be order of n log n in the worst case, right? So here also we can sort this and we can find the fourth largest. So for the fourth largest would be 6, 5, 4 and 3, right? So the fourth largest would be the 3. Okay, you can sort it as well, or so it could be. So how do you optimize this? You are taking order of n log n, and so here this one, if you write it like this, okay, actually this won't be 3, since we need to find the fourth largest, so if we, since the elements are coming multiple times, so it would be 6, 5, 5, 4, 3, 3, 2, 1. And if we are checking for the kth fourth, so this is first, second, third, fourth. So it would be 4 actually, right? So since the numbers can be repeated also, so we need to find the fourth largest. So in this case, this is the fourth largest element, right? So in the brute force way, we can solve it in order of and log n using sorting. Can we optimize it? Yes, we can. How can we optimize it? Using heap. Using heap we will optimize it. So heap we will use max heap. Okay, so we'll have a max heap, and max heap in C++ STL we implement it as like this: priority queue, since it's an integer data type, so PQ. So we have a priority queue. Now if we traverse this nums and we insert all the elements in the priority queue, so whenever we pop out the first element will always be the largest element, and once we pop it out, automatically our heap, this priority queue, the second element, if we take out from the top, it would give the second largest. Okay, so it would be very simple. What we'll do, we'll push all these elements and then we will pop it out till we get the kth element. Okay, and the kth element will be our kth largest element. As simple as that. So for I equal to 0 to nums dot size, so what do we do in the beginning? We push the element pq dot push nums I. Okay. Next, after that we have this much, and now we need to find the kth largest, right? So we will use another loop for I equal to 0, I less than k minus 1, because the kth element would be our value, right? And I plus plus. So we will keep on popping out till we get the kth element. So pq dot pop, right? And now we will return pq dot top, because that would be the kth element, right? And we'll get our answer like this. So I think this is clear. Please study about the priority queue or heap data structure and you will easily understand this. So we have whenever we push the elements to the priority queue, once this is pushed, it is arranged in such a way that the top element in the priority queue, the first element or top element, you can say, that is the largest element in the priority queue list. Okay, so that would be 6 in the beginning, right? So when we have this example, right, if we run this example, so k is equal, so we have pushed all the elements and the top element is 6 right now. Okay, so when we since 0 is less than 2, so we will pop this out. Okay, 6 will be popped out, and automatically in the priority queue the top element would be 5, because that is the next largest element after 6. So now 1 is less than so 0 was less than 2 minus 1, 1. Now 1 is not less than 2 minus 1, 1 is equal to 2 minus 1. So we'll come out of this loop and we will pop out this kth element, that is the second element, first and the second element. So this would be our answer. Okay, so the link to the question has been given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 53rd question of the problem solving series and the first question of heap in the lead code platform, kth largest element in an array. And you can see this question has been asked in multiple companies as discussed, yeah, so this is the simple code. We take the priority queue, we insert all the elements of the array, and then we pop the till k minus 1 elements, and then we return the top element of the priority queue, which is the kth largest element. So we will directly submit this. So you can see this has been accepted. So I hope the explanation is clear, and see you also in the next video where I will be explaining the second question of the heap data structure and the 54th question of the problem solving series. Jai Janendra.